This video will help you with your Module 2 assignment 2.06, Rational Functions and Asymptotes. So the first type of asymptote that you're dealing with is a horizontal one. And so the way you're going to deal with horizontal is you're going to look at the leading or the highest exponent of your numerator and your leading or highest exponent of your denominator. Notice here in the first one, I've got an exponent of 2 over an exponent of 1. So anytime that the numerator exponent is larger than the denominator, what that means is you have no horizontal asymptote. And I'm going to use HA for quick abbreviation. The way I remember this is if your top is too heavy for your bottom, it's going to collapse, meaning no horizontal asymptote. Okay? Here in my second example, I got x squared in the top, and the bottom I've got in my denominator another x squared. So these two are the same. So what that means is that a horizontal asymptote does exist. So what you'll do is whatever the leading coefficient is in front of them, you got 1 over 1. My horizontal asymptote is just that, is 1 over 1, which reduces and simplifies to just 1. So to do the quick example, if I had like x squared, let's do 3x squared plus 5 over 7x squared minus 1. Again, my exponents here are the same, so my horizontal asymptote would just be the 3 over 7. And then in this last one, I got x over x squared, so they're not the same, so the horizontal asymptote is not just the numerator over denominator. The top is not larger than the bottom. My numerator is actually smaller than my denominator. So what that means is that my horizontal asymptote, it does exist, it's just going to be at 0. And those are the three different types of horizontal asymptotes that you're going to deal with. Now vertical are a little different. Vertical, what you're going to want to only be looking at and focusing on are your denominators. So what we're going to do is we're going to take each one, so x minus 5 in this case, and set it equal to 0. So whatever causes the denominator to be 0 means that that domain is not there, and so what's occurring is this vertical asymptote. So you've kind of already done a little bit of this in Algebra 2 and earlier lessons of the course. So I'm going to add 5 to both sides. And I'm going to end up with x is equal to 5. So my vertical asymptote on this one is 5. On the next one, I've got x squared minus 5 is equal to 0. Here I'll add 5 to both sides and get x squared is equal to 5. Then I'm going to square root both sides. And I'm going to end up with x is equal to plus or minus, remembering your square rooting, we've got that plus or minus because of either one of radical 5. So I've actually got two vertical asymptotes here. In this particular one, I've got radical 5 and negative radical 5. You can see it written that way, or you can see it written this way. And for some reason on the third one, I just duplicated the same problem. So you're going to do the same thing here, and you should end up with the same answer. When you're looking for the domain of the rational function, again, the domain, we don't want our denominator to ever be 0. So what I like to do is take my denominator and set it equal to 0 and figure out what, if put in there, would give me problems. So here I had minus 16 on both sides and get negative x is equal to negative 16. Can't have a negative x, so you can either say that you're dividing by negative 1 because that's mathematically what you're doing. Some people know just to change the sign on both. Either way, you're going to end up with x is equal to 16. So the domain, in this case, is going to be all real numbers, and then maybe something like a semicolon or a colon, and x cannot be 16. You could say all real numbers, and literally say except 16. A couple ways you could do it. If you do interval notation, you'd be saying negative infinity up to 16, but then from 16 up to infinity, meaning all the numbers up to 16, but not including 16, and from 16 on, not including 16. So just a couple different ways you may have seen this written before, both in textbooks, maybe previous math courses, or in the lesson or assignments, but just know they all mean the same thing. Just make sure you know how to find the correct domain. And then lastly, you're asked to write a rational function that has a horizontal asymptote at y equals 7 and a vertical asymptote at x equals 7. So we know that for a horizontal asymptote to exist, we need to have the same on top and bottom here. So we know that's going to give me the same thing. So what I would probably do here, just for easiness, I would put like 14 and a 2, because I know that my horizontal asymptote would be 14 over 2, which has reduced down to 7. And then I need my denominator, because my vertical asymptote to be 7. So we can just put 14x. We can put everyone up here, 20x plus 9 if we want. On the bottom, my denominator, I've got 2x squared. I need it to be something that would cause it to be 7. So let's think. So I got 2x squared. Right now I want it to equal 0, but I want to plug a 7 in. And actually what I'll probably do is I make this even easier and actually just do something without quadratics. So what I'll do up top, I'll make them the same. I do an x and x. And what I can actually do is just make the top 7, bottom is 1. We'll again do whatever we want up here. 7x plus 20. And just to make it easier, my vertical asymptote needs to be 7. So let's do x minus 7. Because by plugging in 7 and setting the bottom equal to 0, I'd get 7, and that would cause me to have a vertical asymptote. So there's my example. So don't do like I did in the beginning and make it more complicated than it has to be to where you're having to do all this extra work. Keep it simple, keep it linear, and good luck on the assignment.